Chapter 4, Section 5. Terbitometric measures of microbial cell numbers. Here's an interesting thing. As I've stated many times in lectures, here in the recorded lectures or in class, one cell's too small to see. Billions of them, well, I can't see individual, but I can see the mass. They will make the liquid look cloudy. Well, that cloudiness we refer to as turbidity. While you're not actually seeing individual cells, what you're seeing is that mass of cells that are swirling around in the liquid are interfering with the passage of light. They're causing light to scatter. So that's what your eye is picking up. Hey, do you know we have a way to measure turbidity? It's called a spectrophotometer. Remember, you use spec 20s to measure absorbance of things in chemistry core, in your chemistry labs, in intro cell and cell biology. Maybe we can use these specs to measure turbidity of our liquid broth bacterial cultures. Well, it turns out somebody figured this out many decades ago. They use a spectrophotometer. They can figure out the OD, the optical density, at 540 nanometers. Turns out the higher the OD number, the absorbance, how much light got scattered, correlates to the number of bacterial cells present. Oh, this is kind of cool. Because think about it. In the last section, in section 4, we were talking about doing serial dilutions. Remember, you take a sample from your original broth culture, you put it in, 1 ml into 9 mLs to dilute it. Transfer that over. 1 ml of that to another tube with 9 mLs. Transfer 1 ml. Transfer. You have all these tubes, which you're only going to take 1 ml out of to put on plate so you can get viable cell count numbers. It means you have 9 mLs or 8 mLs per tube still left there. What can you do with that? Glad you asked. You can put it into a spectrophotometer that is set to 540 nanometers. You can then record the optical density. Once you go and you count how many, CFUs, how many colonies per ml, you do the dilution thing, and oh my God, there's 159,000 in this tube. All right, well, that tube had an OD reading of 1.1. So for that bacteria, anything that corresponds close to 1.1 means there's roughly 1.59 times 10 to the 5th bacteria per ml. So you're already going to be doing dilutions so that you can come up with a viable cell count number. So you take those tubes that you've already using for your dilutions and you drop them in the spec. You go through and you record. Boom, 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 boom. Then you do the cell numbers per optical density. And you get this growth curve. What this will allow you to do is the next time you're growing bacteria X in that broth, and you need to know roughly how many bacteria are there, you take a sample of it, you put it into a glass tube, test tube, you put it in a spec, the spec says, ooh, 0.6. 0.6 over to your line and then down gives you the CFU, colony forming unit number. Now you have an idea of, 2 times 10 to the 8th is how many are there. 1 times 10 to the 4th or whatever. Thing is, though, you have to do this for every bacteria. Every bacteria is going to be different. Every bacteria has different growth characteristics, is what they're showing here. If you were to weight, organism A, organism B are going to have different growth characteristics. A just grows faster, which means its numbers are going to be more turbid, which its optical density is going to be higher within a shorter amount of time. B is going to be slower. You could also change this to, to show that A and B, maybe A is a new culture. B is an old culture. So B is getting sluggish, where A of the same species is newer and just growing better. There are so many variables you have to take into account, but it's a great means for showing, hey, look, OD 0.45, well, that corresponds to 3.3 times 10 to the 8th. 3.3 times 10 to the 8th, that's 330 million bacterial cells. Optical density, 0.68 of whatever this one is. I forget what this is. Bacteria is supposed to be. 5 times 10 to the 8th. That's 500 million bacterial cells there per ml. 0.18, 1.3 times 10 to the 8th. And you can sit there and you can dilute this out and work this out and do multiple other dilutions of it to get an even better, broader spread of optical densities, which will give you even more numbers that you can then plot out. Once you've gone through all the work of making the dilutions, measuring each dilution for its optical density, and then plating and coming back the next day and counting per dilution, here's the number of CFUs, here's the total number, blah, blah, blah. That's a lot of work doing it the first time. But then after that, like I said, you take your tube out of the incubator, you transfer 1 or 2 mLs over to a test tube, you drop it in the Spec 20, it says 0.32. Well, based on your graph, because you graphed the numbers, 0.32 corresponds to something times 10 to the 6th or whatever. Done. Hard part's the first time doing it. After that, it's quick and easy.